Hi, welcome to P7.1, Demonstrated Understanding of the Relationships between Oral and Written Patterns, Graphs, and Linear Relations. So oral patterns would be something like counting 5, 10, 15, 20, something like that, that has a pattern to it. Written, obviously, we're just writing it down. So if you had like an input-output machine, one of those input-output, and you put in a 4 and it turns into a 7, so you can say, well, maybe the pattern is that they're adding 3. So if I put in a 5, it has to be an 8, so that would be a written pattern. A graph, something like if you have the growth of a plant or something that you're showing. This could also be done as a linear relation if something is on your graph that is a straight line. Okay, so the indicators, there's tons of them here. Just remember, we only need to really be good at about 3 of them. And a lot of them are very similar. So this looks like it's a big outcome, but it's really going to be just fine. So represent a relationship found with an oral or written pattern using a linear relation. So taking this information and putting it into that there graph. So we're actually going to do one of those in a minute. Analyze whether an oral or written pattern is linear in nature. So that just means, does it make a straight line or is it a curve or something like that? Provide a context for a linear relation. This just means, why are we using them? What is the point? So I've got a few examples of why we use linear relations. Identify a pattern from the environment. So we're going to talk about the growth of a plant. That's my leaf. It's nice, hey? See, I can draw. All right, that is linear in nature, and write a linear relation to describe the pattern. Identify assumptions made when writing a linear relation for a pattern. So assumptions might be that if you have a bar graph, one of those guys, the assumptions could be that these were all measured using the same criteria. So if you're saying what percent of students, this group got 30% on the test, and this group got 40% on the test, and this group got 50% on the test, one of the assumptions we're thinking there is they all wrote the same test. So there's lots of little assumptions that you might want to think about when you're looking at patterns and graphs. Create a table of values, which is basically just that input-output machine up top there, for a linear relation by evaluating the relation for different variable values. So this could be a variable, and if this was 10, we would think, well, what did we do to the x to turn it into a 10? If the pattern said that we had to add 3, then obviously x is 7. Okay, create, down here, create a table of values using linear relation and graph the table of values. So taking that information, putting it on a coordinate plane. Sketch the graph from a table of values created for a linear relation and describe the patterns found in the graph. So you might say, well, here's my graph. It was going up and then the plant started to die. So you might be able to describe that using words. I'm just going to change colors here. We are here. Describe the relationship shown on a graph using everyday language in spoken or written form. Analyze a graph in order to draw conclusions. So you can see those are all basically saying the same thing, or solving a problem. Match a set of linear relations to a set of graphs. Explain the strategies used. So we might give you some numbers like 3 and 1, 2 and 7, etc., and then show you a graph, and you would have to decide if they go together or not. Match set of graphs to linear relations. Describe a situation which could result in a graph similar to one that is shown. Okay, lots. Okay, so we were just talking about patterns on the previous slide, and the one that I was giving you for an example had the same action all the way through. I think we were adding 3 every time, right? So these are simpler patterns. We'll give you even simpler numbers. We're going to start with 2. You can tell that my action here is that I'm simply adding 2 every time. It's the same magical formula every time. Some patterns have alternating actions, so I'm going to start with 2 again just to make it easy. I'm going to add 5. Okay, so I've added 5, I got 7. And now I'm going to subtract 1. Okay, so my pattern is alternating. I'm adding 5, then I'm subtracting 1. So added 5, subtract 1, add 5, subtract 1, add 5, subtract 1. Could go forever. Okay, patterns with increasing actions. So I guess the one we just did has an increasing action, but they could also have decreasing. Okay, so I might start with a large number like 100 might be my starting point, and I'm going to have a decreasing action. So I'm going to go to, let's see, okay, can you tell what my pattern is? I'm simply splitting it in half or dividing by 2. So sometimes you might have decimal numbers inside your graph. That's okay. It doesn't always have to be a whole number. You could measure a plant that was 12.5 centimeters tall. So don't worry about seeing decimals in these patterns. It's just the same kind of stuff. Adding, subtracting, multiplying, dividing. No worries. Okay, so the outcomes say that, or the indicators say that you have to be able to take numbers from an input-output machine or ordered pairs, same kind of thing. This could be your X value and this could be your Y value, or from a pattern and be able to plot it on a graph. So that's what we're going to do right now. So let's say the inputs are 2, 4, and 6, and I'm going to give you a bit of a complicated pattern. I'll see if you can figure it out. Okay, so what number goes there? Okay, so when you're thinking about patterns, you're just trying stuff and trying to figure it out. So obviously this pattern here was easy to figure out, 2, 4, 6, 8. We know the next number is going to be 10. That's easy. You could look at this and think, well, they added 4, they added 4, they added 4. That's pretty easy. You could also think, well, they multiplied by 2 and added 1. Okay, so 8 times 2 is 16, plus 1 is 17. So we're adding 4 every time down here. There's lots of different ways to look at a pattern. Then we can take these numbers that we just filled in our input-output machine and plot them on the graph. So if we're going to do the first one, we always use the x-axis, which is the horizontal. We always do that first. And then the y-axis, which is the vertical, that comes next. So when you're looking at your ordered pairs, we're going to start with 2 on the x-axis. So we start here at the origin, and we're jumping over 2, and we're going up 5. 1, 2, 3, 4, 5. So that is our first plotted point. And then we're doing 4, 9, right there, 6, 13, right there, and I don't have enough space to plot my last one. But you can see that this is a linear relationship, because if I join, now I don't have a ruler, so here we go. Oh, perfect. Look at that. Yeah, not quite. But you get the idea. It would be a straight line if I could draw. Okay, so why do we use linear relations? They're kind of handy in different circumstances if you're trying to figure out a pattern, or if you have something that repeats or something that grows. And so, for example, if you have these tickets to the show, let's see, they are going to be $5 for 1 ticket. But if you buy 2 tickets, they're $9. If you buy 3 tickets, they're going to be $12. Okay? So if you had to graph that, you could use those two numbers as plotted points, 5 and 1, 9 and 2, 12 and 3, or you could even put it on a bar graph like this and say 1 ticket, 2 ticket, 3 ticket, and you price up the side. So for 1 ticket, it's $5. For 2 tickets, $9, and you could see the growth of your tickets. The pattern here, in case you're wondering, so 1 ticket is $5. So 2 tickets should have been $10, but I made it 9. So obviously the pattern here is I'm subtracting $1 for every ticket that you buy. So 3 tickets should have been 15, but I subtracted $3 and I got my 12. So 4 tickets should be $20, but I'm going to subtract 4. And there's the price. All right, if you have money, which I don't, but you might, you never know. This person, you can see he has, looks like $2 here and about 5 here and about, I don't know, 12 here and about maybe 20 there. I don't know. They're a little tricky to count, but he could plot those numbers. Maybe this was day 1. His mom gave him an allowance. And this was day 2 or week 2 or week 3. So you could chart that out on a bar graph and say week 1, week 2, week 3, week 4, etc. And you could see the growth of his earnings. He must have been a good boy, got some allowance. Okay, the last example down here, you could chart the growth of this fine young tree or plant, whatever he is. Looks maybe like a rose bush because it's got thorns. Okay. So you'd have your bar graph, and you're always comparing 2 things, right? So one of them is probably how much did it grow, and the other axis would be how much time. So in our example at the top, this was how many tickets, and this was the cost, right? In this example, this was how many weeks, and this was how much money. So you're always comparing 2 things when you have linear relationships, or, you know, in the case of the plant, it might not be linear because it might be, oh, it shot up the first day and then it kind of leveled off, right? So that isn't a straight line, so you can't say that's linear. There wouldn't be an equation that we could put with that at this point in time, but when you get up into calculus, you can figure out equations for weird curvy lines like that. Okay, so one of the indicators says that you have to be able to look at a graph and explain the pattern or the relationships with it. So this one is just random that I grabbed off the internet. You also need to be able to read a graph and tell me how many people like grapes. So you look at what the grapes are, straight across, obviously 5 people. Okay. But if I said, what's the ratio of grapes to blueberries? Well, blueberries is up here at 40. We do ratio with dots, right? And we can put that into lowest terms. So 5 to 40, I can divide by 5 on both sides. What I do to one side, I must do to the other. So for every 1 person that likes grapes, 8 of them like blueberries. And you could plot that kind of stuff on a chart as well. There you go, linear relationships. Enjoy.